In computer science, different programming approaches are used for solving mathematical puzzles and games. And this course is about one of the puzzles named Tower of Hanoi. The Tower of Hanoi is a mathematical puzzle involving 3 rods and n number of disks. The goal of the puzzle is to move the entire stack to another rod while complying simple rules. In this course, the concept behind solving the Tower of Hanoi using 3 to 4 to n number of disks will be discussed along with programming construct like recursion, which is used for writing programs. The implementation of this problem will also be discussed using Python programming construct. So without any further ado, let's get started right away. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
Hello everyone, welcome to the session where I'll be talking about Tower of Hanoi. So before proceeding ahead, let me tell you what is the agenda for the session. So I'll be talking about the basic concept of Tower of Hanoi. What is it all about? Then, after understanding about the Tower of Hanoi puzzle, I'll be talking about how can we solve this Tower of Hanoi problem using n disk. Okay. Then specifically for 3 and 4 disks, how this Tower of Hanoi algorithm can be solved. I'll be discussing about that. And then I'll be talking about implementation of Tower of Hanoi algorithm using Python programming. And lastly, we'll also analyze the time and space complexity of Tower of Hanoi algorithm. So let's get started. So when I say what is Tower of Hanoi, nowadays Tower of Hanoi we know as a mathematics puzzle. But Tower of Hanoi was given long back in 19th century. It was named behind a French mathematician, Edward Lucas. And it's also called as a Lucas Tower. And this was invented long back in 19th century. Actually, in 19th century, this concept of Tower of Hanoi was used by priests for increasing their mental discipline. So Tower of Hanoi then also was solved as a puzzle, was utilized as a puzzle, but to increase the mental discipline of priests. Same puzzle is solved by us nowadays. So what exactly is this Tower of Hanoi game? Okay, or if I say Tower of Hanoi mathematical puzzle. So in this, it consists of 3 rods and different disks. 3 rods are used in this game on which the disks are placed. So they are disks like, floppy disk, for example, if you have seen, there is a hole in the center. So these disks are stacked one above the another on these rods. Okay, so number of rods or the towers also referred as towers. Number of rods will be 3, but number of disks can be n in number or multiple in number. Puzzles begins with a particular state, that is the source state or starting state, and then you have to reach to a final destination state. And how to reach to the final destination state is the whole concept of this puzzle. Okay, so what is the starting state? So starting state is, suppose this is the rod. Okay, this is represented as a rod. Okay, and this is your flat surface on which this tower or the rod is placed. Then there will be 3 rods as stated in the problem. Okay, now in these 3 rods, the state or the initial state of the game is that there will be disks. Now the disks can be multiple in number. Okay, suppose there are 3 disks here for an example. So the first disk will be stacked, which will be largest in size. The next disk which will be stacked above this will be little smaller in size than the first one. Okay, this is suppose first disk, this is second disk. Third disk will be little more smaller in size compared to the second one. So the smallest disk will be placed on the top and the largest disk will be placed in the bottom. Okay, this is the initial state where there are 3 towers, A, B and C suppose. In tower A, these are the 3 disks stacked one above the other. There can be multiple disks. What is the final state of the puzzle? So you have to reach to the final state of the puzzle from this source state. And the final state of the puzzle is that all these three disks, in the same manner how it is arranged in rod A, should be shifted to rod C or tower C in the same manner. That is, the first disk should be stacked in the bottom, second disk should be above it, and the smallest one should be on the top. Okay, so from this state to this state, you have to reach. Now, how to reach from the initial state, that is all the disks are on tower A, to the final state, that is all the disks are stacked one above the another in tower C in a particular order. That is the largest disk in the bottom, the smallest one at the top. So to reach to this destination, there has to be followed some steps from the initial state to the final state. Okay, and to follow these steps, there are some rules which you have to follow while deciding the steps. And that rules are, the first rule is that none of the disks should be placed on the surface. That is, when you are removing the disk from the rod A or tower A to place it in tower C or tower B, you can place only in these towers. It should not be placed on the surface. Okay? Meaning to shift, suppose you want to shift from tower A, the disk 3 to tower B, you can directly shift it over here, from here to here. It should not be kept anywhere on the surface. This is not allowed. First rule. Second rule, at a time you can only shift one disk. That is, if you want to shift 2 and 3 both of the disk to B, then you have to shift first 3 and then 2. There is another rule that will not allow you to shift 3 and above that 2 disk, but the second rule which I am talking about here right now is that you have to shift only one disk at a time. You cannot shift like all the 3 disks completely together from A and put it in C. Done. Puzzle solved. So this is not allowed. You have to pick only one disk at a time. Okay. Third rule says that whenever you are shifting these disks to any of the towers, may it be tower C, may it be tower B, or it be tower A also. Even at the intermediate steps, before reaching to the final step, final destination, or final state of the puzzle, even in the intermediate steps, the arrangement of disk in any of the towers should be in the order. And that order is largest disk on bottom, and then the smallest one above it. Okay, if suppose you have to place the disk 2 and 3 to tower B, then 2 is the largest disk, then 3. So disk 2 should be below, and then 3 should be over here. It should not be that the smallest one is at the bottom and the larger one than the bottom one is above it. So this is not allowed. So these 3 rules you have to follow. That is, one disk can be moved only at a time. This should be placed on the towers only. You cannot place it somewhere else in the surface or anywhere else. Third rule says that at any given point of time, even at the intermediate step or the final step, the disk arrangement should be in an order. And that order is largest disk should be in the bottom, smaller one above that, and the smallest one above that. So I hope the rule of the game is clear to you, and also the concept behind, the idea behind this Tower of Hanoi game. Now let us talk about Tower of Hanoi for end disk. So when I say end disk, it means what? That in the Tower of Hanoi puzzle, there are 3 rods, 3 towers, they are fixed, but number of disks that are arranged on a single tower can vary in number. That is, it can start from 1 to n in number. The value of n can be anything. So let's try to understand that how is the number of steps figured out in case we have to shift n disk from one tower to the another tower. So suppose this is one tower represented as A, the another tower represented as B, another tower represented as C. Okay. As Tower of Hanoi problem says that there are disks arranged one above the another, right? This is 3 disks. So the value of n here is 3. Okay. So to move 3 disks from tower A to the destination tower, that is tower C, how many steps are required? So for that, we have to shift these and see. That is one way of finding out that, okay, for 3 disks, these many steps are required. Okay, suppose the number of disks here in this is one more, that is 4 disks are there. The value of n is 4 here. Then how many steps are required to move the disk from tower A to tower C? By the help of or with the help of tower B, definitely. So how many steps are required? Still for 4 disks we can count by shifting it one by one and then counting number of steps. Okay, but suppose the number of disks, the value of n is some higher number as 15, or maybe the value of n is somewhat more higher than this as 50. Then in that case, how many steps will be required to shift all these 50 disks arranged in an order? That is, the greatest one will be at the end, the smaller above it, the most smallest above it. In this order, in the same order, if you have to shift the disk from tower A to tower C and the number of disks is 50, then how many steps are required? It is difficult to count manually. Okay, so after analyzing the trend, that is, for one disk, if I ask you that number of steps will be how many? So if I write one disk here, okay, so shifting one disk from tower A to tower C will be just one step. Shift that disk to tower C. If there are two disks here, so number of disk here is suppose 2. Okay, and I have to shift this from A to C. So first I will shift this smaller disk into tower B, and then I will shift this disk into tower C, and then finally B I will shift again to this tower C. Meaning one step to shift the smaller one to B, okay, next step to shift A to C, and the third step to shift the smaller one from B to C. So 3 steps are required in case of 2 disks, right? Similarly, for 3 disk, how many steps are required? So if you count it, like soon, and I'll tell you how in case of 3 disk, the movement is done. In case of 4 disk also, how the movement is done. But as of now, let me just directly tell you that for number of disks, that is n values 3, the number of steps is 7. If the number of disk is 4, then the number of steps will be 15. So if you analyze this trend, it is somewhat 2 to the power 1 minus 1. For 3, if I write 2 to the power 2 minus 1. For 7, 2 to the power 3 minus 1. This is 2 to the power 4 minus 1. Isn't it? So this 1, 2, 3 here in the power is what? Nothing but number of disk. 1 here, 1 here, 2 here, power also is 2. 3, then power is also 3, meaning number of disk is raised here as a power. So if I generalize this further, it will be 2 to the power n minus 1. Right? So number of steps required to move the disk from tower A to tower C will be 2 to the power n minus 1, where n is the number of disks. Okay, so I hope this concept is clear to you now, that how Tower of Hanoi number of steps is calculated in case of n disk. Now let's see Tower of Hanoi algorithm for 3 disks. If there are 3 disks in one of the tower arranged in an order where greatest disk is at the end, smaller one above it, smallest one the topmost, then in the same order, how can you arrange it to the destination tower, that is in the third or the last tower, tower C, if I name is at A, B and C? So let's try to see how we can do this shifting. Here with the help of this GIF also you will be able to understand. So this I am referring it as a tower A. Okay, this is your tower B and this is your tower C. Okay, so to shift from tower A to tower C in the same order, you can see here what is the steps followed. So first you have to move the smallest one into tower C, then the next smallest into tower B, then the smallest one back to tower B, and the largest one from tower A to C. So if I again try to depict it here and also keep a check of it. So the first step will be, if I write this A, B and C and the 3 disks are arranged here. Okay, So first, if I number it as 1, 2, and 3, okay, 3 disks are there. So from A, I have to shift it to C. So how can we do that? So first we will shift the smallest one, that is the topmost disk, into C. Okay, this will be shifted to C. So from A to C is the shifting. Next, I have to shift from the second one, I have to shift it to B. Okay, the second smallest one. So again, the shifting is from A to B. Now, the third step is that I have to shift back. So this smallest one is shifted over here. Now in the tower C, at this particular step, this is how it looks like. In tower A, there will be the largest one. In B, the next smallest, and C, the most smallest one will be there. Okay, that is the disk 1 is here, disk 2 is here, and disk 3 is here. Okay. Now from here, what you have to do is that you have to shift back the smallest one, C, to B. Okay, so from C to B, you have to shift disk 1. Here A to C I shifted disk number 1. From A to B I shifted disk number 2. So now the smallest one is shifted on top of this. So you can see always you have to maintain the order that the largest one should be at the down, next smallest top of it. So right now in C there is no disk. Okay, so I will erase that. In C there is no disk. Now next step will be that you have to shift the third disk from A to C. So the fourth step is that you have to shift from A to C. This is the third disk. Okay, so third disk will be shifted here. This is the largest one, should be shifted over here. So now third one is over here. Okay, now what you have to do is, so now at this step, the tower A, there is no disk, so this is empty. So now what you have to do is that you have to shift the smallest one from B to A. So 1 will be shifted from B to A. So 1 is no more over here. Okay, so the fifth step, what you have to do, you have to shift from B to A. Which disk? The smallest one, that is the first disk. Now in the sixth step, what you have to do, shift this B over here in the C tower. Okay, so you have to shift from B to C, the second disk. And then lastly, you have to shift from A to C, the most smallest one. Okay, so A to C will be shifting the most smallest one. So this is how we will shift the complete 3 disk from tower A to tower C. So you can see in this GIF also it is very clearly depicted how the shifting is being done, right? So the number of steps involved here is 7. So first smallest one went to C, okay? Then the next one went to B, then C went to B, then the largest one went to C, then so smallest one from B went to A, and then again we can arrange from B to this and A to this, right? So this is how this is shifting of all the 3 disks in the same sorted order is done from tower A to tower C. So if you see the overall concept here, guys, so it is that, all the 3 disks which is arranged over here, these 3 disks, the first 2, like leaving the last one, if I consider last one as the first disk, the remaining one, n minus 1 remaining disk, the total disk is n, that is 3, then the remaining n minus 1, that is the 2 disk, the topmost 2 disk, has to be shifted to B somehow. And then A can be shifted to C, and then this can be shifted to C. This is the steps which we are actually performing. Okay, so this is how Tower of Hanoi algorithm works for 3 disks. Now let us talk about Tower of Hanoi algorithm if there are 4 disks in one tower. So this GIF here can easily help you understand that how in case of number of disks is 4, then the shifting is done from the tower A to tower C, that is the source tower to the destination tower, with the help of tower B. Okay, so the number of towers or number of rods are going to be always the same, that is 3 in number. Okay, so A, B and C, 3 towers are there. So you can see the GIF here. So smallest one goes to B first, the next smallest goes to C, then this goes to B, then this goes here, and then this goes to the A. So let's slowly try to understand this as the GIF here is little faster. So A, B and C, 3 towers are there. In the first tower, there will be 4 rods. Sorry, there will be 4 discs. And you have to shift all these 4 into C. So the first step will be to shift the smallest one into the tower B. Okay, so the smallest one will be shifted over here. After that, the next disk, if I number this 1, 2, 3, and 4, so the first disk went to B, the second one will go to C. Okay, and so first from A to B, we move the first disk. The second step, we moved from A to C, the second disk. Then in the third step, what you have to do is the smallest one, you have to move it over here. Okay, so at this point of time, how the figure will look like is here. So this will be deleted, and if I represent this as tower, so right now this is how it will look like. Okay, the smallest one will be on the top, the second one will be here, and this will be the third disk and the fourth disk. Okay, now what you have to do is shift this largest one, that is the third disk, over here. Okay, so this is shifting again from A to B for the third disk. Now the fourth disk has to be shifted finally to C. So what will be done in that case is you can shift the disk 1 from C to A, right? So the smallest one will be shifted to A. So right now how it will look like is here, that this is shifted already here. This will be shifted to the first tower. Okay, the first disk is shifted here. 3 is no more here. 3 is over here. Okay. After this, what you can do, this is also smaller than 3, right? So this will be shifted over here. So 2 is over here. This 1 will be shifted again back over here. Okay. So at this point of time, how the the tower arrangement will look like is here this way. Okay. So yeah. So all 3 are arranged over here. Now this last disk will be shifted to the third one. So I will stop here at this point and tell you that what exactly is the pattern being followed. So what we have to start with, or what should be our intention, that among the 4 disk, among the n disk, the top n minus 1 disk should be shifted to tower B. Okay. Then the last disk can be shifted to C. Then all these has to be shifted to C. Getting it? So this should be our intention. So while shifting the top 3 disks to B, we will be only left with the last disk, which will be shifted to C. Okay. So now A is empty. C is having the largest disk, that is a fourth disk over here. And then these 3 has to be shifted to C now. So to shift from tower B to C, the 3 disk is same problem like shifting or solving Tower of Hanoi for 3 disk, but the tower here is from B to C. Yes or no? So the same thing will follow after that. So till here, the number of steps was uh, A to B. The third disk was shifted from A to B. Okay, so after that, we shifted the first disk to A, right? So C to A, we shifted the first disk, and then we shifted from C to B. No, yeah. So then we shifted the third disk was shifted. Okay, then we shifted from C to B, the second disk. Then in the sixth step, we shifted C to B, the second disk was shifted. Then we shifted from A to B, the first disk. And then the seventh step, we shifted from A to C, the last disk. That is the third disk, right? So A to C, we shifted the fourth disk. Getting it? Then eighth step will be now involving shifting all these to the tower C, right? So how you can do? So right now, if I represent the status of the Tower of Hanoi, so it will be something of this type, right? So in this case, now what you can do is you can shift the smallest one over here. You can shift the smallest one from tower B to tower C now. Okay, this will come over here, the smallest one. The next is the second one. So this can be shifted to tower A. Okay, so this is shifted over here, the second one. Now the third one has to be shifted to fourth, right? But one is the smallest one already there. So you have to shift first this one smallest one over here. So one will be shifted over here. Now you can shift this three over here. Okay. So now this third one will be here. Fine. So right now the status is that in the disk A we have two of the disk, and in C we have 4 and 3 to two of it. So this 2 and 1, the two disk here has to be shifted to C now, right? And B is empty as of now. Okay, if I clearly represent it for you, this is how it will look like. Okay, as of now. So now again the same process has to be repeated. You have to shift these two to C, use with the help of B. So the smallest one will be shifted to B here, and then the last one, that is 2, will be shifted to this, and then this will be the smallest one will be shifted over here. So this is how you will shift all the disks from tower A to tower C. So following this, how many steps will be there more? So there will be 7 more steps to shift this 3 disk from B to C, right? Which were remaining, and then one lastly to shift the largest one. So 8 steps will be there more after this. So 8 steps will be there more. You can count it as well in the same sequence if you write the complete steps. So the total number of steps will be your 15 steps to shift the number of disks, that is 4, from A to C. Okay, so I hope this is clear. Even in this GIF, you can closely, if you watch this, you'll be able to understand that how the shifting of the disk is being done. It is same as what I explained you right now over here. So I hope this is clear. Tower of Hanoi algorithm for 4 disk. Now let us see Tower of Hanoi using recursion. That is, the solution to this problem of Tower of Hanoi can be obtained by the concept of recursion. So recursion is one of the programming concept here, which says that you have to recursively call the same piece of code. So when we convert this concept to programming, it can be defined in such a way that a method is recursively called, a method is called again and again to solve the complete problem. That is, the same piece of code is iteratively executed to reach to the final conclusion. Okay, so now you have to understand that what steps are being repeated, where at what point of time the Tower of Hanoi problem becomes a repetition of the previous steps. Okay, and if you understand that, then the coding you can do in any language with the help of the concept of recursion. Okay, so to understand that, the algorithm which is there is the first step of the algorithm says that you have to shift the top n-1 disk to the helper rod. That is the middle rod, that is your B. If I represent this again in the form of A, B, and C, the 3 rods or the 3 towers, then if suppose you have n number of disks here, 3 disks if I talk about. So in that case, first you have to shift the n-1, that is the top n-1 disk, these 2 disks to tower B. Then only you can shift the largest one to tower C. Yes or no? And once you shift the largest one to tower C, then these two will be till then shifted to tower B, right? So this is what the first step says, that you have to shift the top n-1 disk to the helper rod. And this is your helper rod as of now. Okay, this, if it is considered as your helper rod, this is your source rod, okay, or source tower, and this is your destination tower. Just to have a clear understanding, these are the names given. Okay, destination tower. So this is what it says, that if there are n disks, then n-1, the top n-1 disk has to be shifted to the helping tower, a helper tower or intermediate tower, and the last one then can be shifted to the destination tower. Okay, so the second step says that shift the last disk from the initial rod to the final rod. Okay, from the initial rod to the final rod. This is your initial rod A, final rod C. Now, the last step says that you have to shift the n-1 disk from the helper disk to the destination rod now. Meaning, these 2 disks which you have shifted to B will be now further shifted to C, right? In the same order. Now, to shift these two disks from rod B to C, you have to again start from step 1. That is, the so here the number of disk is 2. So n-1 disk will be the first disk that from the top. So first disk from the top has to be now shifted to the helper rod. So in this case, now the helper rod is A. Meaning I'll tell you again here. So after this point that the first two steps are executed. That is, if there are 3 disks here, then I've shifted the top n minus 1 disk, that is the top 2 disk, to rod C. To the helper rod B. Okay. And the last one was shifted to C. Now coming to the third step. So third step says that you have to shift the remaining n minus 1 disk from the helper disk, that is disk B. So from the helper, okay, this will be helper rod. From the helper rod to the destination rod. Okay. Now to shift this from helper rod to destination rod, again it is a Tower of Hanoi problem itself, right? But this time the Tower of Hanoi problem for 2 disks. That is the 2 disks you have to shift from rod B to rod C with the help of rod A. Getting it? Only the source rod and final destination rod is changing. The helper rod is changing. Remaining things are the same. Yes. So you have to shift this 2 disks from rod B to rod C with the help of rod A. Yeah. So this is a recursive call, meaning you have to again call the first step and second step for these 2 disks now. That is, you have to shift the top n minus 1 disk to the helper rod. So this is 2 disks here. N minus 1 will be 1 disk, 2 minus 1 is 1. So top 1, that is the first disk here, will be shifted to the helper rod. At this point of time, the helper rod is rod B. So this will be shifted to rod A. And the last disk, the second step says shift the last disk from the initial rod to the final rod. And the last disk here is this one, right? Will be shifted from initial rod to the final rod. This is the initial rod and this is the final rod. So this will be shifted from B to C. And then the last step says that you have to shift the n minus 1 disk from the helper rod again to the destination rod. So right now what the scenario is that if I again convert it to another step. So right now there is 1 disk here. This is disk B, rod B, and then in the rod C there are 2 disks already placed. Now the third step says that n minus 1 disk you have to shift from helper rod to the destination rod. So helper rod right now is A. When we were shifting the number of the 2 disks from B to C, the helper rod was A, right? In the intermediate step. So from helper rod, that is A, we have to shift to the destination rod C. Getting it? So there was only 1 disk, so it will be shifted. So you can see here it is a recursive call, right? And recursive call is that first the top n minus 1 disk you have to shift it to the helper rod, and last you have to shift to the destination. Same process, the same 3 steps has to be called again for shifting those n minus 1 disk from the helper rod this time to destination rod with the help of source rod. Getting it? So I hope this is clear here that Tower of Hanoi is solved using recursion. Now let us see the implementation of Tower of Hanoi problem using Python. So I'll be using here Google Colab, an online platform to execute Python codes. So let's go to the browser where I'll be using Google Colab. So here I have already created a file here, an empty file by the name of DOH, that is on Google Colab. Now here I'll start typing the code, okay, for whatever I have to execute. So I'm going to write a Tower of Hanoi problem here, the code for it. So the logic or programming logic is going to be the same, that is your recursion. So with the help of recursion, how can we call the same method in again and again and solve the entire problem? Okay, so for that first you have to define a method here. So in Python, to define a method, we use a def keyword and then let the name of the method be Hanoi. Okay, the parameters to this is again, the first parameter will be the number of rods. Okay, that is your n, and the next parameter will be the first parameter will be the number of disk. Let it be n, we'll define the value of n later on. And then the other 3 parameters will be your the rods from where you have to shift to the given rod, that is the source rod, the helper rod, and the destination rod. So the source rod is going to be A here, and the destination rod will be C, and the helper rod will be B, right? So this is the parameters to this function. Now I have to write here, if the value of n is equal to 0, then in that case it will simply return, right? We don't have to write anything, because if there are no disks, then there is no point of performing the Tower of Hanoi, right? So it will return simply without performing any activity. But if the number of disks is not 0, if it is more than 0, 1, 2, 3, 4 till n, then the code is that first you have to shift the n minus 1, top n minus 1 disk from the source rod to the destination rod. So I'm going to write for that Hanoi shifting n minus 1 from the rod A to rod B via rods with the help of rod C, right? And then the next statement is, so the last rod from A to now will be shifted to C. So for that I'm writing the print statement here so that even we'll get to know the point of action here. So you have to move the disk, or if I write here shift disk from shift disk, let the number be printed, the nth disk from uh, what maybe source rod from A, okay, that is your source rod, to, okay, if I write from, okay, let be over here, okay, because from will always change, right? But it will, if I put it here, it will print always the same thing. So from A to the destination, right? So the destination is C. From N, from source A to destination C. Okay. Now, after this, we have to call the Hanoi again, the last step of the recursive algorithm. So you have to shift the, again, those n minus 1 which was shifted to the helper rod here, to shift these from uh, B, because B is a helper rod, you have to B shift from B to C, but via A. So this is the whole logic. Now we have to define the value of int here. So sorry, the value of n here. So let n be 3, and I'm going to call the Hanoi function here and giving the value of n to be 3, and these are the character values, so A, B and C. Okay, so this is the code for the Tower of Hanoi in Python. Let's execute and see if it runs fine or if there is any error. So yeah, it executed fine, and the output is this. Let's see first there are 7 steps or not. So 1 2 3 4 5 6 7 steps are there. Let's see if it is correct output or not. So first you have to shift the first disk from A to B, then the second one to A to C, then from B you have to shift it to, okay, shift from A to B, then A to C, okay, then from B to C, then from A to B. Okay, so here I think the destination rods is changed. Let's, this will be C, this will be B, because we are shifting from A to C via B, right? This is what is depicted in this method also, from A to C via B. So while calling also you have to maintain the same thing, otherwise we'll get this kind of errors. So now you can see it is correct. Disk 1 is shifted from A to C, disk 2 from A to B, and disk 1 is shifted from C to B again, then 3 will be shifted to A to C, and then again remaining will be shifted from B to C with the help of A. So this is the complete code in Python for Tower of Hanoi. Now let's talk about the complexity analysis of Tower of Hanoi. So talking about the time complexity of Tower of Hanoi, it can be derived in two ways. Two ways you can find out the complexity analysis for Tower of Hanoi. One is the simple analysis method, and the second one is your the master's theorem in algorithms design. Okay, so the first simple method I'll tell you here, that to find out the time complexity of Tower of Hanoi, we know that the number of steps required to shift n number of disks from the source rod to the destination rod is 2 to the power n minus 1. We have seen this with the help of example. In case of one disk, the number of steps required is just 1. In case of two disks, number of shifting required is, first you'll shift the smallest one to B, and then the last one to C, and then the first one to C. So it is three steps. In case of 3 disks, the number of steps is 7. In case of 4 disks, the number of steps is 15, and then so on. So if you try to analyze this, this is nothing but if I represent 2 to the power 1 minus 1, isn't it the same thing? 2 to the power 1 is 2 and minus 1 is 1. Then for 3 also, if I write 2 to the power 2 minus 1, that is 2 to the power 2 is 4, 4 minus 1 is 3. For 7, if I write 2 to the power 3 minus 1, so 2 to the power 3 is 8 minus 1, 7. 2 to the power 4 is 16 minus 1 is 15. So same way, if we analyze this, then we get that the number of steps to shift n disk is 2 to the power n minus 1. Right? Now, if so this is the total number of steps you are performing. So even programmatically, this is the number of steps you have to perform to shift the disks, right? So if I consider this or convert this into time complexity, then the constant terms are always ignored, right? And the remaining ones is taken into consideration. So the time complexity of big O of 2 to the power n is the final time complexity for Tower of Hanoi implementation. Okay. The other method to find it out is you can find out with the help of this. That is the Master's theorem. So the equation here says that to shift n disk, we need 2 into the time taken to shift n minus 1 disk plus 1. Okay. So this says that to shift n disk, we need twice the time taken to shift n minus 1 disk and one more than that, plus 1. So if I tell you to find the number of number of shifts needed, or what is the time taken to shift n minus 1 disk, then if I substitute this tn minus 1 into this equation, what will you get? So in place of n we have to put n minus, so in place of n we have to put n minus 1, right? So here is n, so in this place of this I'll put n minus 1, so n minus 1 minus 1 plus 1. So this will be 2 times of t to the power t of n minus 2 plus 1. Similarly, if I put this for n minus 2 now, because n minus 2 is what we want, so you'll get something as 2 times of t of n minus 3 plus 1. And if I put this or substitute this into this equation, and finally if I substitute this into this equation, going ahead and then substitutions and methods, if you apply and solve this equation, you will end up with having the time complexity of O of 2 to the power n. Okay, so this is the Master's theorem which we apply, but generally also you can figure out by just finding the number of steps required to shift the end disk from one rod to the other rod, that is the source rod to the destination rod. So this is all about the complexity analysis of Tower of Hanoi. Okay, so now let's summarize the content. So in this video, in this session, we discussed about the different concepts of Tower of Hanoi. That is, what is Tower of Hanoi? What is the puzzle or the game behind it? What is the source state and the final state for the Tower of Hanoi problem? And then how we can solve the Tower of Hanoi for n disk, for 3 disk, and also for 4 number of disk. Okay, then going ahead, we discuss its implementation of Tower of Hanoi in Python, and also using the concept of recursion, how we can implement Tower of Hanoi. So all this was discussed. Lastly, we talked about the complexity analysis of Tower of Hanoi, whether it is implemented in any programming language, what would be the time complexity of Tower of Hanoi problem. So this was discussed also at the last. So I hope you like this session. Thank you.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.